Okay, here's an example for total change basic. Problems 9 through 15, very similar to these. Okay, ds dt is t squared. Change in t is 0.5. And our goal is to use right-hand endpoints to approximate the total change over the interval 0, 2. Okay, so right-hand endpoints, you can think of this as, these are rectangles. So we're going to use rectangles with heights given by the right endpoint, okay? And the total change, really what this is, we're approximating the area between t squared and the t-axis. So, okay, that's really what we're doing. We're approximating the area between t squared and the t-axis. Okay. This should make sense if you watch the other video for this section first. Okay, this is meant to be the second of the two videos. All right. Okay, so using so the intervals that we're going to be computing over are 0, 0.5, 0.5, 1.0, 1.0, 1.5, and 1.5, 2.0. Okay, so you may have a similar situation where you have to put these in yourself, and that's where the total change comes in. So you start at the left endpoint of the interval we're talking about, 0, 2, and you go over that much. Then the next interval starts where that one ends, and you go over that much. This one starts where that one ends, you go over that much, and so on. Okay, so we're going to use 4 approximating rectangles. These are going to be the widths of our rectangles. Okay, so we can draw these things in. My first rectangle is that rectangle there. My second rectangle is that rectangle there. My third rectangle is that rectangle there. And my fourth rectangle is that rectangle there. Now, when we compute the area of these 4 rectangles, you can see that this is in fact an overestimate of what we're actually trying to approximate. Right, what we're trying to approximate is the area between t squared and the t-axis. So we're trying to approximate what I'll put in green here. That's what we're trying to approximate. Okay, that's what we're approximating. All right, so we are going to approximate it. You can see that when we compute the area of each of these rectangles, and add them up, we're going to have an overestimate, quite a bit of overestimate. Okay, so for this interval here, right, so I'll have interval, height, and area. Okay, so the height of this rectangle is 0.5 squared. And my area, the area there is 0.5 squared times 0.5. So times 0.5, 0.125. Okay, now for this interval, my height you can see is 1 squared, or 1. My width is 0.5. So my area, 0.5. Remember, area is length times width. So we have the length is always the same, and the height is 1.0 squared, or right endpoint plugged into my function. Okay. Next endpoint, let's see, 1.5 squared times, well, 1.5 squared I found was 2.25 times 0.5, 1.125. Let me just make sure I did that right. 1.5 squared times 0.5. Yep, okay. And now my last bit here, 2 squared is 4. That's the height of my rectangle. 4 times 0.5 is going to be 2. Okay, so now the answer to my problem, right, besides the overestimate, underestimate part, which I just talked about, right? So my approximation, not exactly correct, because remember, this would be the green part I just drew. The exact amount under the curve. We're just approximating it. 0.125 plus 0.5 plus 1.125 plus 2. So the answer that goes in the box, right? So add all those up. 0.125 plus 0.5 plus 1.125 plus 2. 3.75. And of course units. All right. Thank you.